Welcome, guys. We want to understand supports today. This is the very baseline of a structural analysis, and we'll be dealing with supports all the time. So listen carefully. All right. In a structural analysis, our goal is to understand how a structure behaves under loads. This is our load here, F. All right. But before we can analyze anything, we have to understand how our structure is held in place. All right, this cannot be in space. All right, we have to understand how it is held in place. What are the connections to a fixed reference? All right, and these connections that our structure has with a reference frame are called supports. So supports have two jobs. All right, these are supports. And supports have two jobs. They constrain motion. They constrain motion. And they provide us with reactions that maintain our static equilibrium. So the way to understand the forces and the way to analyze the forces in a structure, we need to have supports. And they provide reactions. Because as you know, in Newton's law, F equals ma, if our structure isn't held in place, it would just accelerate. All right? And also, we can define it in another way. Well, basically, any rigid body in a 2D plane possesses 3 degrees of freedom. Three degrees of freedom. And these represent the independent motions the body can undergo, which are translation along the x-axis, translation along the y-axis, and rotation about the z-axis, which is perpendicular to the plane. So we have ux, uy, and theta z. All right. So the entire purpose of a support is to restrain one or more of these degrees of freedom. And for every degrees of freedom a support restrains, it generates a corresponding reaction. A force for a restrained translation or a moment for a restrained motion. So if our support, for example, restrains the translation along the x-axis, we have Fx, or we have Fy, or we have moment. Alright, let's see how this works. Well, first we have the fixed support. This is the most restrictive type of support. It restricts all kind of movement whatsoever. So as a result, we have all the three reactions. And the fixed support means that it is welded to the ground. It has welded the structure to the ground. So then we have the pin support. Pin means there is no moment, so it can rotate freely. All right, you can see it like this or like this. When they show you, actually show you the pin, or they don't, they mean the same. So there is no rotation, there is no moment. And they can also show it in another way. They can show you fixed support with some pin inside it. And whenever you see this pin, it means that there is no moment here. Pin support can be tricky because it can be shown like number 2 or number 3. And the difference between these two is that this one is external. So we have external, and this one is internal. And the difference is that if we cut our structure from here, we have moment inside the beam. But here, if we cut our structure here, we don't have any moment. So m is 0 here. And in number 4, as you can see, these two are the same. Number 2 and 4 are the same. Okay, you can either draw the pin, actual pin, or not, but they're the same. And number 5 and number 1 are the same too, because here, because this is at the end of the beam, M is 0. And here, the pin is actually internal, and it is also at the end of the beam, so M is 0. The next one is the roller support and the sliding support. The roller support is exactly like the pin support, except there are some tires underneath it, so it can go freely in this direction, or here in this direction. So as a result, we only have one reaction for this kind of support. And all of the rules that I said about the internal and external pin also apply to the roller support. But the sliding support, we have a little box here with some tires in it. So it can go freely in this direction, but it cannot go up and down. And since there's 2 tires underneath it, we have moments here. So there are 2 reactions to this one. And they can mix this one with the pin support as well and create something like this. You see, when there's only 1 tire underneath it, it means it can rotate. So in this one, we only have 1 reaction, or you can show this one like this and put the pin here. And this means exactly the same. We don't have any moments in these two. So these are the same. And the number of tires can be 2, 3, 4. It doesn't matter. Just it only matters if it is 1 tire. The next one is the cable support. And it's generally written beside it that it is cable, or it is said in the question that this is a cable. A cable support is an axial member, and it can only sustain tension, right? It cannot resist compression. And its reaction, it can only resist translational movement along its axis and away from the structure, because it can only resist tension. So, like this. And since it cannot bear any rotation, we can also show the cable support like this, like 2 pin support. All right, these two are the same. Well, actually, if we factor the tension thing, these two are the same. But generally in the questions, because it can only resist translational movements in one direction, these are generally the same. So, and then we have the spring supports. Spring supports are non-rigid supports. So, non-rigid. And what it means is that, unlike our previous supports that we assumed 0 displacement, springs allow deformation that is proportional to the applied load that we can calculate by the Hooke's law. So we have axial spring, rotational, and shear spring. In the axial spring, we can calculate the reaction force like this: F equals K theta, and K is stiffness of the spring, and in the rotational spring we have moment equals theta and theta, and K theta means the rotational stiffness of the spring, and a shear is the same as the axial. And the only difference between these two is that this one constrains the movement along its axis, and this one constrains the movement perpendicular to its axis. This one looks like this. And we can also show the axial spring like this, because it looks like the cable supports, right, like this, or like this, or like like this. We can do so many things about them, but they all mean the same. Correctly identifying these supports and their reaction is the very, very first step into the structural analysis, and they will become very, very useful in our journey. Thank you for watching, and follow for more.